Good day, grade 12s. Welcome to our second lesson in our series on work, energy and power. In this video, we're going to pay attention to work done by an object that is on a smooth, frictionless incline. But before we continue with the new work, let's quickly have a look at the problems that you were given at the end of the previous video. If you haven't done them, I strongly recommend that you rather pause this video right now and first go and have a look at them and complete them. Remember, science is not a spectator sport. You will not develop your cognitive functions that you need to master your final paper if you don't sit and do the work as you would do it in the exam. Let's look at our first example. A force of 70 Newton upwards is acting on a block of mass 5 kg that is accelerating upwards over 2 meters. Calculate the amount of work done by the 70 Newton force. I first write down my equation. I fill in the values for my force, the distance over which this object moved, and the angle between the direction it moved and the force, which is 0. And then I get my answer as 140 joules. In my second question, calculate the amount of work done by gravitational force. Still a fairly easy question. Gravitational force is the mass times gravitational acceleration. The distance that this object traveled was 2 meters. And the angle between the direction it traveled and the force that was applied on the object is 180 degrees. So therefore my answer is minus 98 joules. Calculate the net work done on the object. That is the sum of the work done by each force that is acting on the object. The only two forces acting on this object is the gravitational force and the 70 Newton force. So therefore, if I calculate the net work done, I will calculate the work done by the applied force plus the work done by the gravitational force. I've calculated both of those. If I add them together, remember the work done by the gravitational force was negative work. It will give me 42 joules as my net work. Okay, let's have a look at this problem. Here we have a 10 kilogram block that is on an incline. A 10 kilogram block slides down an incline of 30 degrees over a distance of 5 meters, and you can ignore the effect of friction for now. And you need to calculate the amount of work that the gravitational force is doing on this block. Okay, gravitational force is going straight down. And what do we know? The distance over which this block is moving is 5 meters. The size of the force that is going down is mass times gravitational acceleration, which is 10 times 9.8 or 98 Newton. And now all we still need is just the angle between the direction that this block is moving and the force that is going down. So let's quickly see if we are able to calculate that angle. Okay, what do we know? We know the angle between the incline and the horizontal is 30 degrees. We also know that the horizontal and the vertical here is 90 degrees on top of each other. So if we complete this triangle in which the hypotenuse side is just parallel to the incline, then you will see that this force going down, because it's going down vertically, is going to be parallel to the gravitational force. Since this one is parallel to the incline and this one is parallel to the gravitational force, it means the angle between these two will be exactly the same as the angle between the direction that this object is traveling and the gravitational force. And how do we calculate this angle? Well, if we complete this triangle over here, we know that the angle between horizontal and vertical is 90 degrees. They've told us that this angle between the incline and the horizontal is 30 degrees, and we know that the three angles of a triangle together must give us 180 degrees. So there we know 30 plus 90 is going to give us 120 degrees. So this angle must be 60 degrees in order to find the three angles of a triangle to be 180 degrees. So here you are going to apply a little bit of grade 10 maths in order to calculate the angle between the direction that this thing is moving and the force acting on the block. And once you've got that, you can pop in all the different values in your equation. So we have the work done is equal to force times distance cos of the angle. So we know the force that is acting is mass times gravitational acceleration. The mass is 10 kilograms times the acceleration. So that gives me 10 times 9.8 times the distance that this one is traveling, which is 5 meters, cos of the angle between the direction in which it travels and the force, which I just showed you why this is going with why this is 60 degrees. If I calculate all this on my calculator, I get a total net work, or total work done by the gravitational force as 245 joule. Let's take things up a notch by this nice, interesting problem. It's almost the same. A 10 kilogram block slopes down an incline of 30 degrees over a distance of 5 meters, but now I have a 2 Newton friction force that is acting on the block. And the other difference is, I don't only want to work out the work done by the gravitational force, but I want to know the work done by all the forces, or therefore the net work that is done on the object. Before I calculate that, I must make sure that I know what forces are acting on my block. So I draw a free body diagram showing all the forces acting on this block. So I know gravitational force is going down. I know my friction force is going in the opposite direction than the direction that this block is traveling. I know the normal force is 90 degrees to the surface. And those are my three forces that is acting on the block. So now let's slowly go and work out the work done by each of these forces. So let's start with the normal force. If you remember correctly, we've done a similar example before. The normal force, before we don't know what the magnitude of the normal force is, but we do know the angle between the normal force and the direction in which this block is traveling is 90 degrees. We also know that cos of 90 degrees is equal to 0. Therefore, this force must be equal to 0. The gravitational force we've already calculated, or the work done by the gravitational force rather, we've already calculated. So now we know the work done by the normal force is 0 joule. The work done by the gravitational force is 245 joule. And we only need to calculate the work done by the friction force. The work done by the friction force, we've got our formula, W equals F delta X cos theta. So let's go and put in all those values. The angle between my frictional force and the direction that this object is moving is 180 degrees. The object is moving down the slope. The frictional force is acting up the slope. They told me my frictional force is equal to 2 newtons. I know the distance that this object is traveling is 5 meters, so I can add in all those values and find that the amount of work done by the friction force is minus 10 joule. So now if I want to calculate the total work done, I just add up all the values of the amount of work done by each of these different forces. The work done by the normal force, plus the work done by the gravitational force, plus the work done by the friction force. But do pay attention, the work done by the friction force is a negative number, because the angle between the work done the angle between the force applied and the direction in which this object is moving is greater than 90 degrees. As soon as that angle is 90 degrees, your work will become a negative number. And if I do that calculation, 245 minus 10 gives me 235 joule. Why don't you try this one on your own? A block of mass 5 kg is sliding down a frictionless surface as shown below. The surface makes an incline of 25 degrees with a horizontal. Calculate the work done by the gravitational force acting on the block while it covers a distance of 3 meters, and calculate the work done by the normal force that is acting on the block. Quickly try that, and we will give the answers in the next video.